Okay, so let's start writing some code. So the first thing I'm going to do is just to create a sub heading, which I'll call trainer, right? And then um, I'm going to declare the the trainer file because just as we saw in the transform components that it requires a processing function file, the trainer also requires a trainer file that contains all the functions that we talked about in the previous video. So um, let's say declare a trainer module file, and I'll call it trainer module file, and then I'll call that trainer.py. So if I run this, so if you've already guessed, we are going to use the magic write file to write. Instead of opening up another editor and then writing everything, we're just going to do that here. So whatever comes after this line would be written to our um, trainer file. So the first thing we are going to do is let's specify our label key, and let's specify our feature. So what is our label key? Let me use all caps. So our label key is our rating, and then our feature is review. Should be in quotes. And then we have that utility for renaming the feature, so we would also have that here. So we've seen this function already in the when we talked about transformations, when we use the TF transform. So this is key plus xf. All right, so let's go back to our diagram. So the first function I want to create is the gzip reader function. So as you've already guessed, we will use def, and then we have gzip reader function. The gzip reader function takes an argument called file names, right? And let me just add some documentation here, which is loads compressed data, right? And then return tf dot. So what do you think it's going to return? So if you look at what we wrote over here, where we said data set, so this is how you read TF records using, so I'm just going to copy this whole thing. So it's just the same line of code that we are going to use here. Okay, so yeah, and we are done. So this is our gzip reader function, which is just loading the compressed TF record data set. All right, so the next thing we will do is to write our input function. So we will say def input function, and then what are we going to outputs in this input function. So the first thing we are going to put in this input function is it has an argument, so we will call the first argument file pattern. I will explain this argument in a bit. And then we have TF transform output, and then we have number of epochs, and then we have batch size, which I would maybe just leave to 64. And then the output of this is a tf dot data dot dataset. All right. So yeah. So the first argument, the file pattern. So this is a list of um, all files containing the of all file paths containing the example record. So our files, and then the TF transform output is the transformation graph that we defined in the transform function, right? And then the number of epochs. So here this number of epochs is representing so how much how should I say it? How much batches of data should always be made available to our model trainer. So as I talked about, always have a separate process, always having data available whenever the model needs data. So data is always should always be there whenever the model needs to take data and train the model. So we have to specify some number of um, um, epochs of like some batches representing some number of epochs um, that is always available. So if, for example, we can say, oh, we want data to be always available. We want data which is equivalent to 5 epochs to be always available to the model during training. So at any point in time during training, we have that amount of batches of data available. So the model doesn't really hang and then wait for data to be made available to it. So this idea speeds up training of our model, right? Okay, so the first thing we are going to do is to get our transformation graph, right? Now we will pass this transformation graph to our input function. So the first thing we are going to do is let's just get our post transform feature specification, right? So I'll say transform feature spec, and then this will be transform, this is tf transform output dot transform feature spec. So I will just make a copy of that, right? The next thing will be to create batches of data, right? So to create a batches of data, I'll say data set. Then we use another function tf.data.experimental. So I'll encourage you to look at the tf data functions. The tf data is an API for creating how do I say it? like highly efficient data pipelines for machine learning, right? So for data that does not fit into memory, you would have to use TF data or some other API that makes it easy to read data without putting all this data into memory, right? So we have file pattern will be file pattern, and then batch size will be batch size, and then what's is our features. So our features will be the transform feature specifications. How are we going to read whatever files we read in? So that will be our gzip reader function. What is our number of epochs? So our number of epochs should be equal to number of epochs. And then what is finally our label key? So our label key will be equal to the transformed name and then label key, right? So this is how we have finished creating. No, so we haven't finished creating this function. A function should always have a return. So return data set, right? So we have finished creating two functions now, and what else do we have to do? I'll go ahead and say import TensorFlow, because I'm sure we will need, yes, as TF, since we used tf.data and stuff over here. So import TensorFlow as TF. I'm just going to go ahead and also import let me see, TensorFlow transform, TensorFlow uh, so import TensorFlow transform as TFT. I don't think I need some other, obviously, yeah, if we run this and there is some error or something else we need to import, we can take care of that. Yeah. The next function that we would build is our model builder, right? So the model builder is our neural network. So what kind of neural network are we going to consider? So I will talk about that in our next video. Keep watching.